So good morning students. Today we are going to discuss about the round robin scheduling. The name is round robin scheduling. Round robin scheduling. This is one of the scheduling algorithms in order to schedule the number of processes that which are entering into the operating system. For suppose you have logged into a computer and you have opened a word document. Let us say you have opened a word document, and also let us say you have opened a notepad document. What that you have opened? You have opened the notepad document. Let us say this as a process 1 and let us say this as the process 2. So if the two processes has started, then the operating system has to decide whether to so the operating system has to decide whether to take this as a first process, to process this process or this process. The decision of which process has to be executed will be taken by the operating system based on the scheduling algorithms. And whatever the scheduling algorithm that we are going to discuss now, that is round robin scheduling. Round robin scheduling is going to execute the jobs as per a certain criteria. Now we are going to discuss about the round robin scheduling. A round robin scheduling algorithm is used to schedule the processes in a proper manner. So let us discuss how the round robin scheduling works. Okay. So for example, why we are going for the scheduling algorithms? Whenever we have a number of processes which are entering into the computer system, that is the CPU or the processing unit. Whenever there are a number of you know processes which are entering into the operating system, then there should be an algorithm to decide which process has to be executed first and which process has to be executed next. What is the priority? So let us go for the round robin scheduling now. I'm going to share you the document. Yes, this is the round robin scheduling. Let us directly go for the example to illustrate the round robin scheduling. Okay. Here there are three processes P1, P2 and P3 are given. Okay. Let us say there are three processes P1, P2 and P3 which has entered into the operating system. So the duration of the duration of each of the processes, let us look at each of the process. The process P1 will be completed, let us say the process P1 will be completed in 3 seconds, process P2 is completed in 4 seconds, process P3 is completed in 3 seconds. Okay, process P3 will be completed in 3 seconds. Now let us see. So let us see the order in which they have come into the operating system is like this. Okay, the P1 has come in the first order, means P1 has come at first. Let us say P2 has come in the second. So P2 is coming for the second time. Okay, after P2 has come, who is going to come? P3 is going to come. Who has come first? P1 has come first. Who has come next? P2 has come next. Who has come at the last? That is P3 has come at the last. Okay. So what is the arrival time of each of the processes? 0, 0, 0. That means they have entered at the same time. Means as soon as I opened my computer system at the 0th time, means as soon as I enter the computer system, the process P1, P2, P3 has started. The process P1, P2, P3 has started. Right. So let us discuss about the how round robin scheduling is going to work now. Okay, here the time quantum we are supposing to be 1 unit. Do you know what is time quantum? Do you know what is time quantum? The time which is given for each of the processes. I want to give the equal time to all the processes, because some process may take 10 seconds, some process may take 5 seconds, some process may take very less time. So what I want to do, I want to give the equal justice for all the processes by giving the same kind of time quantum to each of them. For example, already explained about this time quantum. The CPU is busy executing so many jobs, a number of jobs are there for the CPU. So if I give 2 seconds for this and 2 seconds for the second process, 2 seconds for the third process, for each of the process if I give the equal time interval, then the time interval which is distributed equally to all the processes, we are calling it as a time quantum. Okay, this is the time quantum. What is the time quantum here? The time quantum is going to be 2 seconds, but here the time quantum is how many? 1 unit, means 1 second is given. So for P1, I'm going to give 1 second. After that, I'm going to take P2 into consideration. I'm going to execute P2 for 1 second. Again, immediately I will shift to some other process, that is P3. Again, I will execute P3 for 1 second. Again, in the round robin manner, means again I'm going back to the P1. Again, I am going to give the 1 second time to P1. Okay, again I'm shifting myself, I'm shifting the CPU to P2, and I'm going to give 1 second for P2, and next I'm going for P3. Like that, I'm going to give 1 second for each of the processes. Okay, for example, here the P1 takes 3 seconds. How much time P1 is going to take? 3 seconds. If I give 3 seconds time at the beginning itself, then the P1 will be completed, right? And after that, if I give 4 seconds for P2, okay, if I want to complete the P2 totally now itself, I'm going to give this 4 seconds of CPU time to P2, but I'm not going to give like that. Whether they have a more duration, okay, whether they have a less duration, no problem. I want to give an equal justice by providing a time quantum of 1 unit for each of them. Okay, let us see how it executes. Let us see this Gantt chart. This is called as what? Gantt chart. This is called as a Gantt chart. Always whenever a problem related to the operating system is given, you need to build a Gantt chart to calculate the waiting times of each of the processes. Okay, so let us go here. Suppose the time quantum is how much? 1 unit. So first, do you know all of them have entered at the same time, that is the 0th time. Now I'm going for P1. P1 has started at 0th second and it will execute for 1 seconds. See here, see P1 has executed for 1 second, then P2 has executed for second. So P2, from 0 to 1, P1 is executed. From 1 to 2, P2 is executed. From 2 to 3 is executed, P3. Again from 4 to 5, sorry, from 2 to 3, right? Starting from that, again from 3 to 4, P1 is executed. Again from 4 to 5, P2 is executed. Again from 5 to 6, P3 is executed. Again from 6 to 7, P1 is executed. Okay, P1. Now P2 is going to be executed from which seconds? Let us say 7 to 8. Okay, which one? Is it P2 or P1? Yes, it is P2, right? Then P3 is going to be executed from 8th second to the 9th second. Now this P3 is going to executed from 8th second to 9th. Again P2 at the last will be going to be executed from 9 to 10. This is a very simple algorithm. Did you understand this or not? Okay, this is something like 9 to 10. I will explain it to you again. It is looking like very rough, no? See, from 0 to 1, P1 is executed. From 1 to 2, P2 is executed. From 2 to 3, P3 is executed. From 3 to 4, P1 again executed. again 4 to 5 P2, again P3 5 to 6, okay, again P1 6 to 7, again here 7 to 8, okay. So again this P3 8 to 9, okay, again this P2 9 to 10, okay. So this is the way how they have been executed. 0 to 1, let us write it very simply. 0 to 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 7, 7 to 8, 8 to 9, and 9 to 10. So this is the way how they are executed. So we are giving the equal time interval, equal time quantum for each of the process, so that they will be executed, okay, in a round robin manner. Do you know what is meant by round robin manner? If you see the round robin manner, from P1 to P3 they are executed. Again it is coming for P1, again it is following the same thing. Again it is coming for P1, again it is following the same thing. This is called as the round robin manner. This is called as what? Round robin manner, okay. So now you have understood what is a time quantum, and you have understood what is meant by round robin, and we have already understood how the time has to be given and how many times, how much time it will be. So here he is saying what is the waiting time of P1? 4. Why? Because do you know what is meant by waiting time? Let us see what is the waiting time of P1. So first we need to write this actually. 1, 2, 3, 4, 5, 6, okay, 7, 8, and 9, right? So what is saying? P1's waiting time is 4. Why is saying P1 waiting time is 4? See here. So how much time the P1 has to be executed? The P1 has to be executed for 3 seconds. But how much time P1 has taken for its execution? Starting from 0 to 7. Okay. Now from this point there is no P1. So P1 has started, arrival time is 0. P1 has started at this place, and P1 has been totally ended at this place, right? Right. So from here to here, let us see how much time it has taken. From 0th second to the 7th second, the P1 has taken a total time of 7, right? Now I have to subtract this duration, how much time it has to be executed. Actually it has to take only 3 seconds, right? But it has taken 7 seconds, right? So how much time it has waited is 7 minus 3 is equal to 4. Actually it has to be completed in 3 seconds, but it has completed in 7 seconds. How much extra time it has taken is 4 seconds. So the waiting time of P1 is going to be 4. Now let us go for what is the waiting time. Now let us go for what is the waiting time of the other process, that is P2. So what he is saying, the P2 waiting time is 6. How you can say the P2 waiting time is 6? Again take P2 where it has started. The P2 has started over here, and where the P2 has ended, the P2 has ended at this position. So from 1 to 10 the total time taken is called as a 9, but the actual time that has to be taken as for the duration of P2 is 4, right? So if I take, so how much time it is taken? From 1 to 10. So 1 to 10 means how much time it has taken? 9 minutes, but the P2 has to take only 4. So 9 minus 4, the waiting time of P2 is going to be 5, but here given is at 6. Let us see what is this. P2's waiting time is 6. Why? Where the P2 has actually ended? From 1 to 10, right? If you go for P1, what is the 0 to 6? Just now we have calculated, sorry, 0 to 5, and yes. So so this, you don't take this, you take the P2's waiting time as 5 only. Okay, so just like that we can calculate the waiting time of all the other processes. So whenever you calculate the waiting time of each of the process, P1's waiting time is 4, P2 and P3 waiting time has given as 6, right? So let us see how this actually, let us go for the waiting time of P3, where the P3 has started at this position and where the P3 has ended at this position. Okay, so this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, this is 8, and this is 9. Okay, P3 has started at the second and P3 has ended at the ninth second. Let us see. So 9 minus 2, how much time it is taken? 7, right? But how much time it has to taken? Has to take 3. So you don't consider this 7. So let us see 2 to 9. So total time it has taken is 7. But actually how much time it has to take? It has to take only 3 seconds, right? So 7 minus 3 is going to be 4. So this is going to be. So the calculation, now tell me what is the calculation? Tell me what is the average waiting time of each of them? We already calculated the waiting time of each of the process. The average, the waiting time of P1, the waiting time of P1 is 4. This is okay. The waiting time of P2 we have arrived it as 5. Actually this is 5, right? What is the waiting time of P3? We already explained the waiting time of P3 from this position to this position, that is 2 to 9, that is 7, but 7 minus 3 is 4. Now tell me, 8 plus 5 is 13. So 13 plus 3 is going to be our answer. So 13 by 3 is nothing but 3 4s are 12 and 1 is remaining. You have to put a point, you will get a 0. That is 10. So 3 into 3 is 9. So 4.3 is the average. Do you know what is the average waiting time? I have to add up the waiting time of all the processes, waiting time of first process, waiting time of second process, and waiting time of third process. And by the number of processes are, how many processors are there? Here we have a 3 processes. This is going to give us the average waiting time. For every scheduling algorithm, you need to calculate the average waiting time. If the average waiting time is less, the scheduling algorithm is more powerful and efficient. And if the average waiting time is less, it is more efficient. If the average waiting time is more, it is less efficient. You always try to see the average waiting time is decreasing. Okay, so this is about the round robin scheduling. Here we have a problem. Actually we have taken this document, but there are some mistakes here. You are going to get the average waiting time as waiting time of P2 as 5 and the waiting time of P3 as how much? We have only 4. Now the calculation is going to be 4 plus 5 plus average waiting time is going to be the waiting time of all the processes by the number of processes, that is by 3. You are going to get something like 4.3. Okay, so don't worry about this document. Sorry, don't worry about this document, but we need to know what is the waiting time. I will again tell you how to calculate the waiting time. Let us take P2. Okay, P2 has started at this position and P2 has ended at this position. This is 1 2, I'm explaining again, 3 4 5 6 and 7 and 8. Okay, so okay, is this 8? Yes. Okay, so 8 minus 1 is 7. So total time taken is 7, but actually how much time it has to take for P2? The P2 has to take only 4. So 7 minus 4. Okay, sorry, 7 minus 4, what is the result? 3. This time we got 3. Anyway, you have to know how to calculate the waiting time, right? Waiting time is nothing but the total time taken by the process to complete. So how much time it has taken from 0, this is 1 to uh, this is 8, right? So 1 to 8 means it has taken 7 seconds, but actually it has to take only 3 seconds. So 7 minus 3, sorry, this is we are discussing about P4, right? P2, right? So 7 minus 4, it is going to be 3. So this is the way how we go with. You have to understand how to calculate the waiting time of each process. So I will revise now what we have discussed. I will share the whiteboard for you. You may have confused with because of the document. So round robin means in a circular fashion we are going to give the time quantum and execute the jobs. Let us say this as p1, let us say this as p2, and let us say this as p3, and let us take the cpu. Now cpu is busy executing the jobs. Now the question here is CPU is going to give the time for which fellow, whether it is going to give time for P1, whether it is going to give time for P2 or P3. This is the question. So actually it is not going to give more time to one process, but it is going to give only 1 second for each of the process. So CPU is going to give 1 second for P1 and it will shift to P3. Again will give the 1 seconds to P2 and will shift to P3. Again it will come to here. Again it will give the second time. Again it will give the 1 second. Again 1 second. Again 1 second. Like this, it is going to give the time to the processes in a round robin manner. So this is called as the round robin scheduling, right? So you have understood what is a round robin scheduling. You have understood what is the time quantum. Time quantum is nothing but the equal time will be given for all the processes. The equal CPU time will be shared for all the processes. CPU is going to give only 1 second for each of the processes. There is no such a process like VIP process, normal process like that. Everyone is given the equal importance and everyone is given the equal time. That is called as the time quantum, right? So waiting time. So we have the formula for the waiting time. A waiting time is nothing but the total time taken, okay, total time taken for executing a job, okay, minus actual time in which it has to be completed. For example, let us say a process P1 by using the round robin scheduling has executed for a total of 8 seconds. Means it has taken a total of 8 seconds. But in the problem, it has given that the P1's duration, how much time it may be completed will be given as 3. So actually it has to be completed in 3 seconds, but it has taken 8 seconds. So 5 seconds extra time is wasted. This wasted time we are calling it as a waiting time for the process. So you need to calculate the waiting time for P2 and P3 also. Let us say for P1 we have arrived a waiting time of, just now we have calculated something like 6 or 4, okay, something like, and P2 has got some other time like 3 or whatever may be the. Now these are the waiting times of P1 P2. Now what is average waiting time? The average waiting time will be the sum of this P1 P2 P3 plus the number of this processes are 3. So it is going to get some value. So this is the same